Hello guys, today we're going to talk about some kind of misconceptions some people have with regards to airflow. So when we have an airfoil, an airfoil is a 2D version of a wing. So if you have a wing and you cut it, if you cut the wing, um, then you're going to see a cross section of the wing, and that is the airfoil. So if we see the airfoil, and some people believe that when air is coming from left to right, or more like the airfoil is moving from right to left, but when we're doing any kind of, I guess, aeronautical engineering stuff, we draw the direction of the wind. So we draw the wind coming from left to right, because they're technically the same thing. Well, this air is actually, well, there's going to be another streamline here. So there's two, but the difference between these two arrows are infinitesimal, so we can assume they're the same. And if this particle right here is A, and this particle right here is B, and it starts at the same location on the x-axis. It starts on the same location on the x-axis, and some people explain that when A and B start from the leading edge at the same time, they have to meet at the trailing edge. So this x distance is going to be trailing edge, and this is going to be the leading edge. They say when the particle A and B starts from the leading edge, that they're going to meet at the trailing edge. And as we can see from the shape of the airfoil, A has to travel much further because the top of the airfoil is more curved compared to the bottom of the airfoil. That particle A will move much faster than particle B. And what happens is they meet at the trailing edge. Well, that logic is incorrect. In fact, I'm going to choose red here. A definitely moves much faster than B, and it doesn't meet at the trailing edge because A is traveling much faster than B. So what happens is A is going to travel until this location. So right here, this is A, and let's say this is going to be trailing edge plus delta x, and this is delta x. Well, particle B will be perhaps at the trailing edge. So this is particle B. So at the in the same time difference, delta t, during delta t, A is at trailing edge plus delta x, and B is at trailing edge. And what happens is, due to friction in fluid, and shear forces, since the bottom airflow is slower than the top airflow is curved towards the bottom, and there's some kind of a downwash that causes lift because of Newton's third law. So the way airfoil or wing generates lift is not a simple Bernoulli's principle. In fact, it's a very interconnected physics problem. But in the core of it is Newton's third law, where if the airplane wants to go up by generating lift, well, there has to be something that's pushing down, so which is the downwash. So if you guys are interested, go look at what downwash is. Go look at a little more detailed explanation of how airfoil generates lift. But in this video, I want you to basically get rid of your idea that when two particles that is infinitesimally close together, and they start from leading edge, and particle A goes over the top of the airfoil, and particle B goes underneath the airfoil. They're not going to meet at the trailing edge, but A is going to be traveling much farther compared to particle B. So I hope that helped, and I'll see you guys in the next video.